Okay, so finally we're going to be talking about the second part of this long title that has been on the last few lessons, and log functions. Okay? Now, today is going to be a very new concept, but I'm going to build it entirely on everything that you've already learned. So, even though it's a new concept, we're going to use all of the last unit to be able to help understand it. Okay? I actually want you to turn to the next page. And we're going to talk about this thing called a logarithmic function. A logarithmic function is an inverse of an exponential function. Okay, now, in general, we write y equals log b of x rather than x equals b of y to express the inverse of y equals b to the x. Okay, now if that makes sense, you must be very weird. Okay, so just think of the sentence again. In general, we write y equals log b of x rather than x equals b of y to express the inverse of y equals b to the x. Okay? I'm going to try to explain that to you at the very, very top of your page here. So I want you to write y equals b to the x. Now, if I went and did an arrow like this, and on the top of that arrow, I want you to write what would be the inverse? X equals b to the y. Does that make sense? Okay. This is an inverse on x equals y, right? Now remember last unit, we always did that, and then the question would often say, get it in the form y equals. Now, how am I supposed to get this thing in the form y equals? I have to use this new thing called the log. Like, if I switched x and y, is that getting into the form y equals? No, that's finding the inverse again. I'm back to where I started. So you need to understand why we need something now. Not just, we're going to learn something now, and you don't get a need for it. Okay? So the question is, I need to get this to y equals. So I'm going to take this and change it to this form, y equals log b of x. Now what should I put on top of that line, that arrow? What word? What can you tell me? Now the first two are inverses of each other, right? So I wrote inverse. What are the other two? Are they inverses? They are the same, so they equal each other. Now, let's kind of think like a mathematician for a second. Why is the letter B used there? Base. What do you see in, that's log B of x? Do you see, that's called the base in both of them. So to go from x equals b to y, this is called the, just so you know, this is called the exponential form. This is called the log form. Do you first see what happens? B stays as the base for both of them. And what happens to x, y? They switch. So x, y gets switched and the word log gets put there. Now do you see how this can get very confusing? Because to go from original to inverse, you switch the x and the y. To go from exponential to log form, you switch the x and the y. But what's the difference? You put it in log form. Okay? So, what word would you put above this line? What are these to each other? Would I write the word inverses or equal? Inverses. So that is what this says down here. In general, we write y equals log b to the x rather than x equals b to the y to express the inverse of y equals b to the x. Okay? But what more importantly, know this top chart that we just did together. Okay? If exponential is y equals and log is y equals, they are, okay, so this is called exponential too, right? This is exponential. So y equals b to the x and y equals log b to the x, because they're both y equals, they equal each other. Are you starting to see the rules that you need to learn for these? Okay? Now, just so you are familiar with the actual form. This is y would be the value you're looking for. B is the base, and x is called the argument, but let's just call it x. Okay? Now, here's two graphs. X equals 2 to the x, and x equals 2 to the y. They are inverses of each other, therefore they should be a reflection on y equals x, right? Okay, do you see how they are reflections of each other? Now, here we have y equals 2 to the x. Here we have x equals 2 to the y. Now, what is the equivalent form of x equals 2 to the y? What's another way to write x equals 2 to the y? Y equals log 2 x. So these two are the same. So y equals 2 to the x and y equals log 2 to the x are inverses of each other. Now let's fill in this table because this is a very, very, now let's look just at the blue graph right now. This is the blue graph. What would be the domain of the blue graph? X in the reals. How about the range? Y has to be greater than 0. X-intercept? None. Y-intercept? 1. Asymptote? Y equals 0. Now, y equals 2 of x. What is the domain? We're doing the red graph now. What is the domain? X is greater than 0. The range? Y is in the reals. X-intercept? 1. Y-intercept? Asymptote? Any generalizations you can give me about log form versus everything switched. Now remember, that's what we learned before. when you do a reflection, when you do an inverse, which is a reflection of y equals x, domain or range switch, but also x-y intercept switch and asymptote switch. This is something that, do you know this? The diploma wants to know, do you know this? Okay? So even when you're making your notes, as you're doing them, you should write, put on study sheet. Okay? Something like that, so you can start to generalize. The diploma wants, can they generalize? Can they do it over all of x's, all of y's? Okay? Now, let's go down to this chart at C. Now, I actually don't like how they write it this way, and you'll see why I think there is a significant difference of the order you write it. Now, if I'm going to take it from log form to exponential form, now remember, log form and exponential form are the same if you do it right. They are only inverses when they're both y equals. When exponential and log are both y equals, they're inverses. But do you see how, on this chart, if this is x and this is y, we're actually going to switch the order, which makes them equal. Okay? And if you change to the right form, which is exponential. Now, what number does not move? The 2, because 2 is the base. So this is how it should be written. Now, what should be the exponent on top of 2? 3, which equals 8. So you may not at this point, log 2 to the 8 equals 3. Some of you are going to look like I would know that. But remember, these two are identical. Does log 2 to the 3 equal 8? Yeah, okay, I get that one. Okay? Okay, now log 2 of 4 equals. Does anybody know the answer to that? Well, let's put it in exponential form and see if you can get it. This would be considered y out here, right? So we would go 2 to the y equals 4. So you rewrite it. Then ask yourself, what is y? It's 2. So just cross that out, put a 2. So this must be 2. So log 4 of 2, or 2 of 4 is 2. And 2 to the 2 equals 4. Okay, what's log 2 of 2? Okay, well, let's call that y right now. So let's change it to exponential form. Remember, when I put it into exponential form, they're equivalent. Two to the y equals 2. So by looking at this, what is y? 1. Put a 1 there, 1 there. Are you seeing how to do this? Okay? Hopefully through redundancy, you'll get it. Log 2 to the 1 equals y. Continue doing these in red, okay? So my new form would be 2 to the y equals 1. What do you think y would equal? 0. And if you put that in your calculator, which you don't really get to use today to be able to solve these. Okay. Now we're going to go backwards. If let's look at exponential form. 1/8 is 2 to the negative 3. Does that make sense? What do you think log 2 to the 1/8 is? Or 2 of 1/8 is? It's negative 3. Okay, so if I'm to rewrite this next one, this would be log. Now, what would be that little number that's lower? What would it be? 2. Okay, we're getting that part. Now, what's going to be the number beside it? 1/4 equals negative 2. This one will be log 2 of 1/2 equals -1. Okay, if you had this, let's write it in log form. Okay, Graham, what would be the answer to that in log form? Okay, remember, think of this. Log b to the x equals y is the same thing as b to the y equals x. Yeah, log 10, because this does not, it stays as base, and the other two trade. These two trade. Remember? Okay. Equals. And that's a correct statement. I mean, you may not know that right now, but once you get good at logs, you'll be able to go, yeah, that's right. Okay, next one. Let's get that into exponential form. Okay, Amy, at the back. Very good. Again, that is a true statement. Now, the whole purpose of this, to find that exponent. Okay, so remember the graph of an exponential. It goes like this, right? And that's 1. Sorry, of a log. That's a log graph. Remember what exponential? Exponential looked like this, right? Now remember, these two are inverses when they're both in the form y equals. But when you take one and actually do the switch, they're the same. And by switch, I mean switch those and put a log. If it was exponential and log, okay? So look at this graph. This should make sense. X-intercept is 1. Yeah, there is no y-intercept. It's never going to go through. Horizontal or vertical asymptote was 0. X is greater than 0. Y is in the reals. And remember, these two forms are equivalent. Y equals log b to the x is equivalent to x equals b to the y. And b is the base of both the logarithmic and the exponential function. Okay. Now, these are very, very key ideas right here. The logarithmic equation y equals log b to the x can be expressed in exponential form x equals b to the y. And the exponential equation of y equals b to the x can be expressed in a logarithmic form as log equals b of y equals x. Now, here's something to know, that x is only defined for positive values of x. So the log of a negative number cannot be determined, okay? So if you look here, do you see why, if you gave me the question, log of 10 to the negative 3. Well, negative 3 doesn't even exist for logs. You see the graph? Can't use negative 3. Can you use x equals 0? No, we can't even use x equals 0. So all your x must be, so for this, x must be greater than 0. Okay? That's a really important, if you look at the graph, That should make sense. Okay. Now, let's do the inverse of each and then answer in the form y equals. Now, y equals log 3 of x. What would be the inverse of this? Jared, what would be the inverse of this? No. What have we always done when we found an inverse? Switch the x and the y. So what is the inverse? Good. Now those are inverses of each other. Now, I'm not done. It says get it in the form y equals. So Jamie Bell, how would I get that in y equals? And what happens with the x and the y? They switch. Oops. 3 to the x equals y, right? Now I got it in the y equals form. So remember, the whole point of before when we were doing was you switch them and then you got all this math to do to get into y equals. Remember, you'd have to divide and right? It was easy switching the x and the y, but then all this work came when you had to get y equals. For this, we switch the x and the y to give me the inverse. These two are inverses. These two are equal. Okay, next one. Y equals 8 to the x. Okay, Colton, what would be the inverse? No. Well, like it, yeah, but let's do the inverse first, and then we'll talk about getting into y equals. So actually, that's not wrong. So you actually skipped a step. Maybe you're just good at skipping. But okay, what Colton did isn't wrong. I just actually want you to see why this works. Now to get this into log form, Colton, you can finish up. Okay, so I want you to understand that those two are the inverse, and then that's in log form. Now, what Colton's going to figure it out is if you make them both equal y equals, just change that, put a log 8, okay, and then these two would be inverses, right? So that's a quick way to get from here to here. That's more of just kind of memorized, where I'm just, there's two things we always have to know. Switch those two, and then to get exponential to log, to actually get the equivalent, I've got to change it. If it is exponential, change to log. If it's log form, I've got to change to exponential. Okay? Now, we're going to take each of these and turn them into exponential form. So we're going to do B, C, and D. Okay, so what would B look like? We'll do these together. Jamie Prinz, get this to exponential form. Okay, good. Next one. This is all variables, but nothing changes. Alyssa? Good. Yeah, good. Okay, next one. Greg. Okay. So you're thinking the 4 belongs to the 6? Out of just instinct, where would you think the 4 goes? Right? Do you see how it belongs to the 5? So take the time to make this step. If you make that step, do you see how it looks like all the rest now? So Greg, what would we do? Good. So I don't know if you want to put a, that might be something you put on a study sheet, right? Okay. So we're going to do A, C, and D. Now we're going to change from exponential to log form. Okay. Is there any Prince in here? Oh, she's absent on me. Okay, Sienna. Okay, and just so you know, and not that there's going to be an oral exam on the diploma, but we say log 4 of 64 when it's in log form. Okay, it's not really 264, it's log 4 of 64. Okay, so it's going to be weird. Some of you guys may never get it, right? But just think that it is different there. Okay, Lauren Pierce. Next one, C. Good. Now, I'm not doing it very good. The E should be lower and the F should almost be the same level as the log. Okay? Okay, and D, Stephanie? Okay, good. Now, if you have pure redundancy of this unit, these will get easier and easier. Okay? Now, here is an excellent diploma question. Excellent. Now, calculate the value of t. Okay? So, and highlighters come in handy here. If you actually highlight it, then you know you're looking for that thing, right? So I got to find t. And they say log 2 of x equals 3, and log 2 of t equals x. Any of you out there think you could get this question today? Good. T is 256. Okay, Jamie, the next thing you have to do is share how you got that. Yep. What would that be? Okay. Now, what is 2 to the 3? I would agree with that. Now, we know that this is 8 here. So what'd you do next, Jamie? Yeah. 256 equals t. Now, that doesn't look so bad anymore, does it? Okay. Now, do you see why some people get 5% on the diploma when they haven't been there all year? This is a question that I bet you none of you could have got on Friday. Okay? So picture that student that's like missed all year and they show up and you're like, what are you doing here? Oh, you write the diploma. Really? How come? Might as well take a chance at it. Why not, right? Um, how are they going to get this question, right? It's not that hard of a question, but you can see the amount of work and you see the amount of time it takes. This is a 30-second question, right? Going nice and slow, systematic. But if you haven't been to this class, you're probably not getting that one. Now, this right here is another thing that, of course, we should really know. Okay? Y equals a b to the x, or y over a equals b to the x. What would that be in log form? Log what am I writing? B of y over a should equal x. Okay. Let's put these in log form. They're all in exponential, I think you can see. We're going to do B, C, and D. Okay, Vanessa. In B, let's get it to log form. Okay, before you start this, is every number where it should be? You can't take the 4 and multiply by 7, right? Because it's got an exponent locking it up. That 4 is to an exponent k. See the 7 goes to it should belong to the other side, right? So we should have this before we even write it in log form. So we're going to write log. Vanessa, what would be the base? Sorry? No, the base doesn't change. What's the base in the original question? No, the base is the thing that's to the exponent. So the 4 should be the base, and then the other two trade. So this should be the h over 7 should equal k. Okay, this next one is in pure variables. Melanie, how should we do this one? Okay, so what would it read? Okay, in log form. Good. Log 5 of p over r equals p. Okay, the next one. Oh, it's supposed to be an s. Where did I get a 5? I can't even read my own writing. Log s and t over r equals p. Okay. D. So good one for you, Alex. What should I do here? Okay, what would it be if I brought it to the y side? Good. So you got 2y over 3 equals 10 over x. Okay, finish it off, log form. Good. Okay, these I want in the form y equals a b to the x. We'll just do b and d. Okay, Wiley, what should I do? Okay, let's just get into exponential form first. What's the base? Okay, so it would be 10 to the what? No. No, these two trade equals y over 4, right? Now, they want it in the form y equals ab to the x. No, this number will come up in front of here. So it'll be 4. Now, you don't really need the brackets there, but that's a good way to show times, right? Okay, last one. Luke? What's the base? Okay, and finish it off. Okay, good job. Okay. So today's really quick, okay? It's all about, okay, I think pretty well everyone got this done in class. So you guys should focus this week on obviously having no homework for the long weekend for you. But it's another math guilt-free weekend, right? If you get your math done on Wednesday, all of it done, and have your study sheet done on Wednesday, you really don't have to think about math all weekend and not think that you're getting behind, that I'm, okay? So maybe you got other subjects, maybe you got essays due, whatever.